Good morning everyone. Welcome back to Doc GILMAC online tutorial. The topic I will be discussing for today's tutorial is all about the cardinality of a set and the cardinality using Venn diagram. Before discussing the topic for today's tutorial, let's have first a simple warm-up drills. Letter A. Write the following set builder notation in roster or listing method. Number 1. Set A is equal to the set of X such that X is an even prime number. Now, let's recall first what is a prime number. When we talk about prime number, this is simply a number having a factor of 1 and itself. So take note of that. So if we are to look for the element of set A, we simply have one element for set A, and that is equal to 2. So set A is just equal to 2. Okay? So this is just an example of a singleton set or a unit set, which was discussed to you last time. Let's have number 2. Set B is equal to the set of X such that X is an element of n less than 11. Again, what is n? This is simply a natural number. And when we talk about natural numbers, these are what we call counting numbers. So from 1, 2, 3, 4, 5, 6, 7, 8, and so forth and so on. Now, if we are to determine the element of set B here, there are only 10 elements. Take note, 11 is not included. So we have set B is just equal to 1, 2, 3, 4 up to 10. So take note of that. Now let's have number 3. Set C is equal to the set of X such that X is a traffic light color. Okay, so we have only 3 elements. So that's green, yellow, and red. Okay, so it's a very basic colors for the traffic light color. So wala naman ng iba. Huh? So take note of that. Now let's have letter B. Write the following roster or listing method in set builder notations. Number 1, set D is equal to 1, 3, 5, 7, 9. Now if you take a closer look on the given elements of set D, these are all odd numbers. Odd numbers which is less than 11. So therefore, the set builder form of this set is simply set D is just equal to the set of X such that X is an odd number less than 11. Then we have number 2, set E is equal to 5, 10, 15, 20, and 25. So if we are to take a closer look on the given elements, take note, these are all multiples of 5. Multiples of 5 less than 30. So therefore, set E is just equal to the set of X such that X is a multiple of 5 less than 30. Number 3, set F is equal to face mask, alcohol, thermoscanner, ... Again, let's recall what are the 3 dots here. Take note, this is what we call an ellipsis. An ellipsis gives you or shows you rather that there are still elements that are to be written here in set F. So take note of that. Okay? So if we are to take a closer look on the given elements, again, these are all PPEs. Personal Protective Equipment. Okay? So we have set F is equal to the set of X such that X is a personal protective equipment. Okay? So these are all PPEs used in combating or preventing COVID-19. Okay? Now, let's define what is the cardinality of set A. The cardinality of a set A refers to the number of elements of set A. It is denoted by n of A. Simply the number of elements of A. So let's have an example. Determine the cardinality of set A. How many elements of set A do you see here? Alright, there are 3 elements. So therefore, n of A is just equal to 3. Okay? Now, let's have example number 2. Determine the cardinality of set B. Again, how many elements do you see here for set B? Yes, there are 4 elements. So therefore, n of B is just equal to 4. Since set B have 4 elements. Number 3. Determine the cardinality of set C. Is just equal to the set of X such that X is an element of Z positive less than 8. Take note, Z stands for the set of integers, positive integers. So positive integers are 1, 2, 3 up to positive infinity. Take note, it's less than 8. So 1 to 7 are the elements of C. So therefore, n of C is just equal to 7. Since set C have 7 elements. So take note of that. Now let's have example number 4. Determine the cardinality of set D, which is just equal to the set of X such that X is greater than negative 5 but less than or equal to 1. So if we are to determine the elements of set D, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. Take note, since this symbol here, less than or equal to 1, 1 is included in the elements. So therefore, there are, yes, 7 elements. So n of D is just equal to 7. Now, let's have example number 5. Determine the cardinality of set E, which is just equal to the set of X such that X is an element of n less than 11. Take note, again, n is a natural number or simply a counting number. So, since 11 is not included here, so there are 10 elements for set E. Therefore, n of E is equal to 10. Okay? Now, let's have John Venn. John Venn is a famous mathematician who introduced Venn diagram and extended Boole's mathematical logic, and is best known to mathematicians and logicians for his way of representing sets, diagrammatic way of representing sets, typical subsets of the universal set, their unions, and intersections. So, that is simply John Venn. Okay? Now, let's have an example using the Venn diagram. Consider the Venn diagram below. List the elements of the following sets using roster method and determine the cardinality of the given sets. Okay. Using Venn diagram, I should say, this rectangle here represents the universal set. So take note of that. And this circle here represents a set. So let's have this as our set E. Then we have here another circle here, which is our set B. Okay. So here are the elements. So as you can see here, all of these belongs to the universal set. 1, 2, 3, 4, 5, 6. So the elements of the universal set are 1, 2, 3, 4, 5, 6. So therefore, n of u is equal to 6. So take note of that. Now, if we consider this circle here, this is our set A, right? There are only two elements, that is 1 and 4. So we have set A is equal to 1 and 4. Therefore, n of A is equal to 2. Okay, so take note of that. Now, if we are to consider this another circle here, we actually have three elements for set B. And we have 2, 4, and 5. So, set B is equal to 2, 4, and 5. So, therefore, n of B is equal to 3. Since the set B have three elements. So, take note of that. Okay. Now, let's have example number 7. Again, we consider Venn diagram below. List the elements of the following sets using roster method and determine the cardinality of the given sets. Okay. So let's have this universal set. Then we have set A. Okay. Then we have set B. Alright. So as you can see here, set U is just equal to EDUCATION. Okay? Education. So how many elements does set U have? So we have 2, 4, 6, 8, 9. So there are 9 elements. So therefore, n of U is equal to 9. So take note of that. Then we have set A. This is our set A, right? So as you can see, set A have 2 elements. And we have C and D. So set A is equal to CD. So n of A is just equal to 2 since A have only 2 elements. Okay? Then we have set B here. Okay, whose elements are C, T, and I. So take note of that, C, T, and I. Okay, there are only 3 elements, so therefore n of B is equal to 3. Okay? Now, let's have example number 8. Again, we consider the Venn diagram below. We list all the elements of the following sets using roster method and determine the cardinality of the given sets. Okay? So again, we have the universal set. This time, we have 3 sets here. Okay? Set A, set B, and set C. Okay? Alright. So we have here the given Venn diagram. So as you can see, the universal set, all of these elements, A, B, and C, belongs to the universal set. So take note of that. So 1 to 8 are the elements of the universal set. So therefore, there are 8 elements. So n of U is equal to 8. So take note of that. Now, what are the elements of A here? So this is our set A, this circle here. Yes? So as you can see, we have 2, 3, and 4 to be the elements of A. So the elements of A are 2, 3, and 4. What is n of A? So that is simply equal to 3. Yes, equal to 3 since there are only 3 elements for A. Now, how about B? If we are to take a closer look on this circle here, we have 3, 5, and 7. Yes? So, set B is equal to 3, 5, and 7. Again, n of B is equal to 3 since there are only 3 elements for set B. Okay? How about C? This is our set C. So, we have 3, 4, 5, and 6. Okay? So, set C is equal to 3, 4, 5, and 6. So, there are 4 elements. So, n of C is equal to 4. So, take note of that. Now, let's have example number 9. Again, we consider the Venn diagram below. We list all the elements of the following sets using roster method, and again, determine the cardinality of the given sets. Let's consider again the Venn diagram here. Okay. So again, we have 3 sets here. Okay. Right. Let's have the elements for the Venn diagram. So we have set A, B, and C here. Okay. So let's have this. Okay. So actually, if you take a look on this Venn diagram, all of the elements of A, B, and C here belongs to the universal set 1 up to 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n of u is equal to 10. Yes? Now, if we take a closer look on this set here, set A, there are actually 4 elements, and we have 1, 2, 8, 10. So 1, 2, 8, 10. So therefore, n of A is equal to 4 since the elements of A are equal to 4. Okay? Okay, then we have here set B. There are actually 3 elements for set B, and we have 5, 8, and 9. So therefore, n of B is equal to 3. Now how about C? This is our set C, right? So we have 2, 5, 6, and 8. So therefore, there are 4 elements for set C, and n of C is just equal to 4. Okay? Again, I would like to thank you for watching and stand by for my next tutorial. Again, may God bless us all.